We're going to pull back the curtain on one of the most basic yet kind of mysterious parts of our daily lives, electricity. I mean, where does it actually come from when you flick that switch? Let's trace it all the way back to the source.
Seriously, think about it. It's something we all do dozens of times a day without even thinking. But that simple little flick, it's the final step in a truly incredible journey.
The second you do that, you're tapping into this giant, complex web of power plants and turbines and wires that spans the globe. It's a fascinating system, and today we're going to follow that current all the way back to where it all begins.
So let's start our journey right here, inside our own homes, and start to unpack what is really going on behind that outlet on the wall.
Okay, so the foundation of this whole thing is what we call energy resources. A good way to think of these is like the giant batteries for our entire society. They're the raw materials, the natural systems that hold all the energy we need to turn into the electricity that, powers our lives.
And right at the very beginning of this whole process, we as a society face this really fundamental choice. It's like a fork in the road, and the path we take defines everything about how we get our power. And that choice is between two main categories. On one side, you've got your non-renewable resources, things like coal and oil. These are finite. There's only so much of them in the ground, and once we burn through them, they are gone for good. But on the other side, we have renewable resources like wind and solar. These are, for all practical purposes, limitless. The sun's going to keep shining, the wind's going to keep blowing.
So why does this choice matter so much? Well, it's a huge deal. Burning a lot of those non-renewable resources releases carbon dioxide. That's a greenhouse gas. And the scientific consensus is clear that this leads to global warming, which has some really serious real-world effects on our planet. We're talking melting ice caps, rising sea levels, and way more extreme weather. So yeah, the stakes for this choice are incredibly high.
Okay, so let's take that first path down the fork in the road. Let's look at the non-renewable resources, the finite fuels that have been powering the industrial world for more than 100 years.
The big ones here are, of course, fossil fuels, coal, oil, and natural gas. And the name really says it all. They are literally the fossilized remains of ancient plants and animals from millions of years ago. It was their incredible energy density, basically these concentrated pockets of ancient sunlight, that fired up the Industrial Revolution and built the world we live in today.
So how do we actually get electricity from them? Well, most of the time, it comes down to this brilliantly simple four-step process. First, you burn the fuel. Second, that incredible heat boils water, which creates a ton of high-pressure steam. Third, that steam gets blasted against a turbine, which makes it spin like crazy. And finally, that spinning turbine is hooked up to a generator, and that's what produces electricity. Now remember this process, because we're going to see it pop up again.
And this really gets to the heart of the trade-off with fossil fuels. On the one hand, they are incredibly reliable. You can turn on a power plant and get electricity whenever you need it, 24/7. But that reliability comes with a pretty steep price. They're going to run out eventually, they release CO2 and other nasty stuff, and just getting them out of the ground can really damage the environment.
Now, another major non-renewable source is nuclear fuel. But here, instead of burning something, we're actually splitting atoms apart. It's a process called nuclear fission, and that creates a tremendous amount of heat. And what does that heat do? You guessed it, it boils water to create steam to turn a turbine. It's the exact same method, just with a completely different and way more powerful heat source. And to really get a sense of the mind-blowing power of nuclear energy, just look at this number. To get the same amount of electricity as just 1 single kilogram of uranium, you would need to burn 14,000 kilograms of coal. I mean, the energy density is just off the charts. But just like fossil fuels, nuclear power comes with its own really big trade-offs. The upsides are huge, a massive power output with zero CO2 emissions. The downsides, though, are just as massive. You get this radioactive waste that stays dangerous for thousands of years. And there's always the risk, no matter how small, of a really catastrophic accident.
All right, let's hit rewind and go back to that fork in the road. We've explored the finite fuels, so now let's go down the other path and dive into the super diverse and pretty fascinating world of renewable resources.
So the two most famous renewables are obviously wind and solar. Wind power is pretty straightforward. The wind blows, it spins a huge turbine. Simple. Solar is even more direct. It uses these special cells to turn sunlight straight into electricity. Both are fantastic because they're clean, no CO2, and the fuel is free. But their big shared weakness is reliability. They only make power when the wind is actually blowing or the sun is actually shining. Water is another amazing renewable source. It doesn't matter if it's the controlled flow of water from a dam for hydroelectric power, the daily rush of the tides, or the constant motion of waves on the ocean. The principle is always the same. Use moving water to, you guessed it, turn a turbine.
Now for a really cool one. What if the Earth itself could just boil the water for us? Well, that's the whole idea behind geothermal energy. In places with a lot of volcanic activity, we can literally drill down and tap into the Earth's natural heat, using it to create steam to drive our good old friend, the steam turbine.
And this right here is geothermal's superpower. As Stuart Gilfillan from the University of Edinburgh points out, unlike wind and solar, the Earth's heat is constant. It's there 24/7. This makes geothermal plants incredibly reliable, sometimes even more reliable than fossil fuel plants.
And finally, we've got biomass. This is basically just burning organic stuff, like wood chips or even food waste, to create heat, which, then drives that same steam turbine process we know so well. It's often called carbon neutral because the idea is that the CO2 released when you burn it is balanced out by the CO2 the plants soaked up while they were growing.
So, we've journeyed down both paths now. We've seen the finite fuels, we've seen the everlasting energies. Now it's time to bring it all together and really look at the big picture.
And this table really lays out the core dilemma in black and white. On one side, you have sources like coal, super reliable, but they pump out a ton of CO2. On the other side, you've got wind and solar. Zero emissions, which is amazing, but they're way less reliable. And then you have nuclear, kind of sitting in its own unique spot, as reliable as coal with almost no CO2, but it comes with its own very serious set of challenges.
And that leaves us with the million-dollar question, doesn't it? What this whole thing makes crystal clear is that there is no single, perfect, silver bullet solution. Every single energy source we've looked at has a complicated list of pros and cons. So what is the right combination, the right mix to power our world reliably, affordably, and sustainably? That is the great energy challenge of our time.